Welcome everybody to the March 2002 meeting of the Astronomical Society of Frankston. As you probably would have gathered, there are a few cars out in the car park because there's a school function currently going on next door where we normally go around for tea and coffee, but we've been told that we'll probably still be able to have tea and coffee around there if they get out in time. For those of you who are new to the Society, my name is Peter Skilton, and when it comes to tea break, a little bit on halfway through the meeting, if you are new to the Society or a visitor, feel free to come up and say hello, and I'll point you in the direction for tea and coffee and someone to look after you. Since we last met, and I can see the numbers are a bit down tonight, we've had Bruce Tregaskis in hospital, but he's out and he's quite alright now, and also my mother, Peter Skilton, who's been a member for quite some time, has been in hospital, and in fact is still in hospital. I'd also remind you to put your name tags on, please, if you can, particularly for the newer members. There's a possibility tonight that we might have a Japanese exchange student coming along. Doesn't speak very much English, but has never seen the southern sky before. And if that actually eventuates, I'd like to ask for some volunteers to come forward during the tea break time and actually take them outside and show them the jewel box and a few of the things up in the southern sky. Now, the Japanese one was not Laurie McIntyre, who was bowing appropriately. There's also the usual $1 raffle and prize, which I'll hand around the raffle now. And the prizes are 2 books, one of which is Patrick Moore on Mars and Comets, Creators and Destroyers. So I'll pass that round, 2 prizes. And I'll also pass around the idea suggestion question box. If you have any questions that have to do with astronomy or any suggestions, please feel free to put it on there. Anonymously is quite fine. And I'll also pass around the viewing night roster for the upcoming school viewing nights and public viewing nights. If you can help with those, much appreciated. Because the proceeds from those go towards helping to develop the rise a bit further and other things in the Society. Reminder that memberships are nominally due 1st of January. If you haven't renewed your membership yet, then please do so. Our volunteer treasurer tonight is Don, who's standing up so you can see him. Just look for the curly hair, and he'll gladly renew your membership for you. If you're in any doubt as to when your membership renewal date is, please look on the mailing label of any edition of the newsletter, Scorpius, that goes out to you, because every edition that goes out, it indicates what you're financial up to. It says the month and the year. Now, the last edition of Scorpius has already gone out, so hopefully you've received yours if you're financial. If you're grossly financial, you probably didn't receive it. in which case please come forward and see the membership. Yes, if you're grossly unfinancial, then you wouldn't have received it. Congratulations to the following members for reaching their membership milestones. We have the 5-year mark, Keith Weddle and Tony Murphy. At the 3-year mark, we have Adam Marsh. And new members recently in, Kathleen McGuinness, Vicky Meeses, Jessica Spitterden, Colin Thompson and Darren Moore. Any new members here tonight? Oh, we got some tonight. Well, welcome, and please make yourself at home, and do come and see me at the tea break, and I'll point you in the right direction. That's right, come on through. That's all right, come on through, sit on down. Right, a reminder that during the tea break, which is halfway through, the library is open if you wish to go around there and borrow any books until next meeting. And our librarian tonight, as usual, is Andrew Thornton, who's over there with his hand in the air. And he'll make you most welcome round by the library. Also, after the tea break, we'll be coming back into 2 sessions. One, I'll actually be talking in here all about the Cranbourne Meteorites, a tale of deception, lies and sex and other sorts of things. Quite intriguing. And next door will be the video going on at the same time about Woomera. In other words, it's an excellent video showing what Australia has done Woomera-wise, and I don't mean throwing children overboard or ships or anything like that, or detaining refugees. This is more the heyday of Australia's time in building rockets and rocketry, when we were right up there with the Americans and the British before we decided to pull out of the race. Right, the library has also acquired some books for advanced amateurs, which will go into the library. They haven't been catalogued yet. One of them was donated by Ian Sullivan, kindly, the Cambridge Guide to Astronomical Discovery, and that's all about how to find novae, comets, variable stars and supernovae from your backyard, and what to do when you do find them. And 3 other ones. There's video astronomy that David Girling ordered some time ago, or put us onto. That's everything you ever want to know about using a CCD camera to do astronomy. For the mathematically inclined, we have astronomical algorithms, which tells you everything mathematically that goes on in the solar system and how to actually go about calculating it on your computer. So that also contains even the latest algorithms on the E5 algorithms from Jet Propulsion Laboratory on how to calculate the eclipses of Jupiter's moons. So you can do those from scratch. And the last one is star testing astronomical telescopes. That one tells you all the ins and outs in great detail of how to make sure the optics on your telescope are correct and how to go about it. So you won't see those in the library this month, but certainly next month you will. Right. In the news, you probably would have noticed that there was a bit of a near miss with an asteroid up to about 100 metres across. Came about, I think, 1.5 times the Earth-Moon distance from us, so a near miss. And they didn't detect it till it actually went by. Just for comparison purposes, the one that flattened Tunguska in Siberia in 1908, absolutely flattened 2,000 square kilometres of forest completely flat, was only about a 60-metre diameter.
Excuse me, it was 2.5 times.
It was 2.5 times, yeah, was it?
Yes,
I thought it was 1.5, but never mind. And this particular one was double the diameter, which means energy-wise it's at least 4 times the energy of the Tunguska one. So if that had actually impacted anywhere on Earth, it would have been a catastrophe of absolutely biblical proportions. But we're here tonight. Viewing nights in the last month we've done here. There was a public one at the Rhinos on March the 1st that was 98% clouded, but we had about half full of that one. There was the Monash University science teachers trainees went down to Lord Somers Camp at Somers, where Ian Sullivan did the talk on that one, and that was about 95% clouded. There was 100 of them down there. On March the 13th, Woodley Senior School Year 8s, they were 100% clouded, and we had about 95 down there, and they showed us great hospitality, and very welcoming school, that one. And on March the 14th, Camberwell Grammar came down to Camp Mannion, and there were 100 there with 100% cloud. And the talk was done by Richard Pollard, wasn't it, on that night? Right, social happenings. There was a solar day held on the 3rd of March. Do you want to say anything about the solar day, Ian?
Very briefly, we were clouded out. So nobody came that wasn't there already from the working day, and just unfortunate. Still have to try again another time. I don't know where you can find a day when you definitely have to have the sun, and but there it was. I did bring sun clocks. That's a plastic sun clock. I sold a few last year, and you make it to kit. You make it up, make a little equatorial sundial. They're $3. The kits, and I got a new supply. So, and the instructions of how to do it. So, a bit better than Peter's paper. It beats that, but then you got that for free, didn't you? $3, and there's some videos there. That's where the box of the sun clocks, and you'll see me later.
Okay. Anything on the working bees? Any feedback or upcoming working bees? Any specific tasks?
The next working bee, I think, is April the 7th that we'll be on, and we've got to do some work on the caravan. So for those people that want to come and help us, we need some work on the big telescope again as well. And there'll be probably a little bit of gardening work to be done as well. So, and there could be a bit of concrete pouring as well. So as many members as we can get there, especially those people who do use the briars, please come up. Thank you.
Thank you. There's a scope and binocular teaching day coming up on the 20th, which I think is some sheets of paper that we're holding out. You want to explain about that one?
Okay. Last meeting I mentioned that we're going to have a telescope day where we can teach you how to use your new telescope, and handed out these flyers. I'll hand them out again. Now, we asked for a minimum of 6 people. I've got 1 so far, so I need 6 or it's not going to happen. So those people, I've actually changed my email address, so I'll just down, there's only about 10 of those, so only take one if you really want one. And be in contact with me as soon as possible. We get our 6 people, we can have a good day and show you how to use your telescope, star charts and all that sort of stuff. So I'll hand those around, just pass them along, and yeah, give me a call or give me an email if you're going to, if you want to come along.
Thanks, Dave. And throw over to Ian Sullivan's a basic weekend astronomy classes. Do you want to mention something on that?
Yes. There's been a bit of talk. Some people have made suggestions to the plate, and I put an ad in the newsletter about running a class in astronomy, basic class, rather than mixing it in with our monthly meetings. Monthly meetings, you are caught with time, having sufficient time. The other aspect is anybody doing it, of course, then misses out on what else is going on the program. So that's the reason for it. However, if you only got very small numbers, then we're more or less committed to that. So the idea is to use a weekend, like a Saturday or a Sunday, half a day or a day, still haven't tied it down to something like that. For people interested, primarily in theory, because you'd be doing that in the daytime, but you'd be able to do a bit of practice, particularly with the sun. But that's the sort of thrust of it, and maybe 1 or 2 or 3 sessions. Again, it will depend on the people concerned. So we've got to get a sort of a database of people interested in doing a course at a weekend in the daytime, and we have to get a venue. We have to pay for the venue, and of course that means we've got to share the cost between the people. You might be able to get a venue very cheaply, but we have to have, the main thing is we have indoors. Of course, we get to the winter time, that's another healing somewhat. Also, blackout will be important because we need to show slides. So that would rule out the odd place. So if anybody knows of a venue, you also know of what time you'd be interested, like Saturday, like Sunday, that sort of thing. I can start taking down data. One chap's phoned me up already. I haven't had a wealth of phone calls so far. So now there's 2 ways to speak to me. One's the meeting, the other one is phoning me up at home. And we gather up. No good just people saying, oh, it'd be great to have a course. We've got to sort of get it into some sort of concrete form, and it's got to be workable. And I'm prepared to try, and we'll see what can happen. Thank you.
Brilliant. Right, the what's on is going around, so if you haven't picked one up yet, hopefully you'll get it by the time it gets to the back, and send the spare copies down to the front for any newcomers that come in. Since we last met, there were 2 lunar grazing occultations, expeditions carried out in the dead of night. One was on March the 9th, which was a Saturday morning at Balnarring at 4:30 in the morning. 3 stations were set up for that one, and we got 20 events. It wasn't my weekend. I forgot my tripod for my telescope, so I actually did that one with my telescope resting on the card table on my knee, but nevertheless got 9 very good events for that one, and the Geelong Society and the ASF as well participated. So 3 societies did that one from either side of the bay. 2 days later, on March the 11th, there was another graze expedition. This time this was the Labour Day Monday morning. At 6:25, went out to Bayswater North and got 4 stations set up for that one. And again, it wasn't my day because my tape recorder failed and pulled the tape to a spaghetti. So it twisted and self-destructed. And that was the end of that one. Though I saw 4 very good events, but that wasn't worth a razoo. Geelong Society and the ASF also participated in that one, so again 3 societies working together for that observation. Occultation-wise, there's a minor planet coming up on March 24th and 25th, which is asteroid 1008 La Paz, actually named after the capital of Bolivia in South America, and its path is virtually east-west, right over the top of us. It's at quite a reasonable hour. It's 3:11 in the morning, which isn't too bad. Unfortunately, it's a Monday morning, so for those of you who have to get up the next day for work, it's a bit of a stress. Any member observations to note since we last met? I notice a lot of our active Nova observe you and that are not here tonight, unfortunately. No comments? No aurorae?
I did read in the paper about the Iraqi comet at the National Park, California. It's 341 years every time it comes round, and it was here in 1661. And it's going to be soon again. Something like that.
Very good. Look forward to it. Okay, well...
well, there was a photograph of it, so it's recent.
Right, okay, yep. Maybe you can bring it along to the next meeting, Carl, if you prefer the newspaper. All right, well, we'll go into the information service now. A couple of our regulars aren't here. Ian Porter with the satellite launches and everything is not here tonight, as is Bruce Chagaskus on the solar and stellar segment isn't here. And Marty Rudd isn't here as well. He's the Meteors one. So what we'll do is we'll start off with David Gurley talking about members' nights, followed by Roger Giller.
Good evening. Viewing nights this month were on March the 9th and 10th. I think when it comes to being in an astronomical society or doing astronomy, probably the foremost thing that most people are interested in is looking through a telescope. Unfortunately, we don't get too many people that do that up at the Bryce, but the people that do come up do have quite a good night. And on March the 9th and March the 10th, which was a long weekend, we had to put up with fairly strong easterly winds. Roger Chandler came up with the Society's telescope. After it was out of collimation, we collimated it, worked very well. Rob Heale with his LX90 computer-controlled telescope, John Cleveland with his 6-inch. Russell Thompson attempted to come along with his 10-inch on the Saturday. It lasted about 10 minutes, the telescope started spinning around in the wind, he jumped back in his car and went home. He had enough. Richard Pollard came along with his 90mm refractor. And We used the ASF's 12-inch telescope, but that was blowing like a sail as well. The bigger they are, the more they spin around. So we had a little bit of fun on that night trying to control the telescopes in the wind. I think the two telescopes that worked fairly well in the wind were that one that's quite small and Bob's LX90. There was a few observations made. We had a few new members come up. Vicky came up with the children, and Jessica came, a new member, and we tried to show them a few of the sights in the southern sky that we all enjoy, like to see. And unfortunately, it was just a bit difficult because of the wind. But I think we all ended up going home at about midnight, 11:30, something like that. It was a pretty good night. The next night, Sunday night, Roger and myself, Mark Heale with his Takahashi telescope and Bob turned up as well. And the wind was still blowing, but it had died down a bit, and it was a little bit easier to view. And probably by midnight, I think it was fairly okay. There was a few interesting observations that night, and one was Ganymede was coming out of occultation, and then a couple of hours later going into eclipse. Roger had never seen that before, and neither had Mark. So it was good to show them what an eclipse disappearance is like. And Peter, we did timing. We tried to do a timing on it. We had the radio going and all that sort of thing. And for some reason, we had interference with the shortwave radio. So there was one problem. The next thing, the tape recorder didn't work very well. There was another problem, as you well know. And then the scene deteriorated so bad that everything was jumping around. And then there was the wind and everything else. But we still made a recording, and I'll send that off. So that was a little bit of fun. But it was interesting to watch the moon go into the shadow and slowly but surely disappear. And because the scene was so bad, everyone sort of saw it disappear at about the same time. We saw many deep sky objects that night, our usual favourites. It was still blowing a fair bit, so it was a little bit hard to see some of the newer ones. But Bob's telescope was jumping around from one to another, which was quite interesting. And we actually liked it. There was one object we were looking at, was a Sombrero Galaxy. We've all sort of seen that before, but there was a star just above the Sombrero Galaxy. I have one chart that plots it at 13.6 magnitude. I have another chart that plots it at about 13th magnitude, so I'm not exactly sure what magnitude it is. But we were just seeing how easy it is to see whether we can see it in the 5-inch, in the 8-inch, and the 12-inch. Now I thought with the verted vision we could see it in all the telescopes fairly well. The 12-inch, it was sort of fairly well there, but I don't think the 12-inch was working that well the second night. The mirror had sort of come loose again, collimation was out. With the 5-inch refractor, which was most interesting, how well we could see that star. With the verted vision you could see it fairly steadily, looking straight at it, you couldn't quite keep it steady. So that's not too bad for a little 5-inch refractor underneath fairly light polluted skies. A couple of other things we looked at, and one interesting object that I tried to look at was something that I saw in Sky and Telescope magazine, and that's this here, this what's called the dark doodad. Very interesting little dark nebula. Now, in the photograph there, it sort of doesn't show it. It's actually better in the magazine. I thought, oh, this should be interesting to look at. Fairly well defined sort of dark nebula. I've seen a few dark nebulae before, and they're not too bad. But this is a little globular cluster here, which not too hard to find. I found it quite easily with the LX90, and the other scopes just start up to it quite easily as well. Fairly faint globular. But then right next to it, the dark doodad starts. And I was sweeping backwards and forwards and sweeping backwards and forwards. And I was saying to Roger, I can't see this dark doodad, what's going on here? But what it is that on the photo, it looks small. And then because of the photos, it's over its 3-degree field, which I sort of didn't get quite in my head. So it's a lot larger than what I thought. And it's not as defined or not as easy to pick as what I thought either. I used an LPR filter, and that did help a little bit. I was using the 12-inch, and then Roger was using the 8-inch. But I eventually did find it and notice that basically all it was that from here I was sort of scanning across and then just noticed that the stars disappeared. There was no stars for a little bit. And then followed where there was some stars, but not many, just the odd one or two. And then followed this dark line up for a few degrees, and then went from one side to the other and then figured, oh, that was it. And so we did observe this dark doodad, so to speak. So that was pretty good. Other things that we did look at were, how well it shows up in this. It's in that area there, a lot of people know it. See the Cranberry Nebula and things, clusters 3532, which is one of our favourites, and a lot of other different clusters and things as well. But one highlight of the night, which is quite interesting, was in there's Crux. Yeah, there it is there. This constellation here is Musca. And because we were exploring in that area of the night, and I asked Bob to confirm this globular cluster near this dark doodad, and he went there and that was fine to confirm that. I just recently purchased Euronometria 2000, 2 editions of Sky Atlas and the Deep Sky Field Guide. I've only used it a couple of times, but it's one of the best atlases. It is the best atlas that I've ever seen and used. The Deep Sky guide is excellent. It's, you have to sort of use it to see it to appreciate how great it is. But in the charts, in their Deep Sky Field Guide, it's got globular clusters, galaxies, and stuff like that. But it's got a little section, Bright Nebula. I thought, oh, this would be interesting. And I had a look down because we're in this area, and this was on chart 209 or whatever. And I said to Bob, oh, do you mind putting the LX90 to IC 2948? And after a bit of persuasion, he finally got up, punched in IC 2948. The little telescope went beep beep for just for a couple of seconds. It didn't move very far. And there was this bright nebula in there. And we're all quite happy, and Bob was quite astounded, and everyone was pretty happy at this nice little nebula. But the reason I picked this nebula was Mark Hillen is a chicken farmer. And he breeds chickens for Equinox. And he has lots of chickens. You want to see his place? There's so many chickens. But this IC 2948 bright nebula is commonly known as the running chicken nebula. And I thought it was very good to find an object in Muscat called the running chicken nebula. And I've never ever heard it before, never heard of it or anything like that. Here it was in Euronometria. We found it, and it was quite bright, quite interesting, and I will be going back when I get my scope to have another look in that area, and I thought it was excellent. So I thought it was very well, a very nice nebula to finish the night off with, the running chicken nebula. So well named for Mark, he was quite happy with that. And it was very interesting. Now, one of the interesting things was, and probably which I thought was pretty good, was when you have a guide like the Euronometric Deep Sky Field Guide, and you've got a computerised telescope sitting there, you can just pick out a number and just punch in a number and off it goes, and you find it, and there it is. Sometimes it'll be there, sometimes it won't. I don't think all those deep sky objects in Euronometria will be able to be seen in the 80s, definitely not. But it has sections, as I said, where it says bright nebula, and most of those should be able to be seen in an 80s telescope. So that and a computerised telescope is a very good companion. You don't need one. You can start up to all those sort of things. But it was interesting just to sit there and hear Bob moaning away and all this other going, hey, you want to go to Bob? And oh yeah, okay. And there it was. So the night was quite good. Again, that was we've had February the 16th. March the 9th and March the 10th viewing night. So we've been fairly lucky so far this year. So hopefully, with most viewing nights being available on Friday or Saturday nights, now I don't necessarily will be there Friday or Saturday. I'm not going to commit myself to moving Friday or Saturday night, but you're most welcome to go there and use the observatory site and view the dark doodad or the running chicken nebula. Good luck in finding them.
Yeah. The auroral activity this month has been, since the last meeting, been pretty slow. 20th of February, just after the last meeting, there was an eruption from magnetic fields from sunspot 1925 region. projection, which I think I can show you. It works. See there on the shot from the SOHO spacecraft, and the floating disk looking at the inner terrain of the Sun. The white circle sort of represents the dome of the Sun where it will be hidden behind the disk. And it's like a time lapse of this projection of mass from the terrain of the Sun coming into the heading towards the Earth. There was an increase in X-ray flux and some other data which I didn't manage to get from, so I think you see there the sort of shot up around here, sort of thing that's gone up quite markedly. But
You can go out this
no
way.
activity. Everyone was sort of waiting for something to happen. Nothing happened at that time. March the 1st, there was the interplanetary magnetic field near the Earth went south, and there was a minor storm, and we get across some lights. The interplanetary magnetic field at the shock wave front or bow front, where the Earth's magnetic field and the interplanetary magnetic field meet. The Earth's magnetic field at that point is tilted to the north, or faces north, the light field lines point northwards. The interplanetary magnetic field, basically, which comes from the Sun, flips and flops between north and south, depending on the rotation of the Sun. You can imagine, like, you know those hose sprinkler lawn watering things which have got like a couple of jets of water out and they sort of spin around and you get this spiral streams of water. You can imagine that, the magnetic field of the Sun. And depending on which way it sort of interacts with the Earth's magnetic field, two can sort of reinforce each other or tend to cancel each other out. When the interplanetary magnetic field turns south, it tends to cancel out the north component of the Earth's magnetic field, and then the magnetic field weakens and allows the charged particle streams from the Sun to pour in towards the Earth's atmosphere and give rise to auroras. And it did trigger some high latitude auroras, this particular event. And then, just again, Science windmill. Far from Norway.
Ladies?
On a bright red globe, typically red on the top and fading off to white or sometimes green below. Green curtain. And this fellow in Norway, what I like about this fellow is his novel form of insulation on his roof. It's like a pair of mattresses popping on the roof. It just keeps the house warmer with that on there than what it would if it was exposed to the minus 20-degree atmosphere. Your Christmas card stuff. Quebec, Canada, this fellow was working under pretty difficult conditions. A lot of local light spilling off from street lights and the snow-covered ground and brightened the sky, but you could just see the faint aurora there across the top half. Very, very faint compared to what's around. It looks like daylight there almost, but it's just a time exposure under nighttime conditions. Faint green in the top left there. Since the same event, this Yuichi Takasaka, he's from up in Alaska. Took a couple of photos, same event. See the typical pattern of the vertical curtains, and they were very sharp cut-off at the lower point. Some of them closer than others. Then there's some there which are, these here, actually closer to us, and these are further away, and sort of looking more in the distance at the bottom of those curtains there. Also, we did it's not in it. It's not too bad though, it just shows this was almost overhead, that particular display. It's sort of cycling through the 4 different images of it. A couple of days later, there's a coronal hole developed in the sun, in the corona. The solar wind speed increased, and it's not just a little increase, and it goes up from 400 to 700 kilometres per second. It's a fair jump in the wind speed, but there was no auroral activity, possibly because the independent magnetic field direction was not right, it was still north pointing. March the 15th, there was a very long-lasting flare erupted from sunspot 9866. Sunspots or sunspot regions are numbered, and a lot of the sunspot, that one there shows you where this sunspot group is. So this is only 3 days ago, 7th of March. It's not really all that easy to see there. That's the same area in sort of highlights a little bit that same sunspot region there. So on that concept, that's quite a big sunspot pair, that one. These sort of flares usually result in coronal mass ejections, and once again this was the case, and Soho. Or data image from Soho, it's missing from it, and all sorts of things. Just a still, once again, the coronal mass ejection, this big loop out around here, especially blasting away from the sun. Sometimes these are sort of pointed towards the Earth, and sometimes they're not. As the coronal mass ejection came past the Earth, there was once again a fair increase in the solar wind speed from 300 up to about 500. But the interplanetary magnetic field was again pointing in the wrong direction. These graphs here show a number of components of the interplanetary magnetic field. I won't try to confuse with what all various ones are. This BZ component here. You can see it's sort of hovering around about 0, and then it developed about a 15-degree north component. It had been south down here and it went to the north, and although there was a coronal mass ejection increase in solar wind speed, it didn't result in the auroral activity at all. And the same sunspot 9866 erupted again on March the 18th. Another coronal mass ejection. And so this one could trigger auroras when it swept past our planet on the 20th or 21st of March. Now we had an aurora alert came out in regard to that, warning that. I think I sent it around to those people who were on the aurora list. I kept an eye on it for a while last night, until midnight anyhow, both on the net and also looking at the sky, which is not a bad thing to do. And nothing showed up, basically. It was a bit of an increase, but nothing to warrant any chance to see anything at our latitudes. There was a late report I got this afternoon which said there had been some auroral activity at high altitudes, but there was no details on that yet, but there were some auroras seen for short periods at high latitudes. So hopefully the next month we'll have a bit more about that. And the sun's fairly active, sort of several large spots, and there's fairly strong evidence of a second peak in the sunspot maximum. As you know, we're now at, or supposedly just past the current peak in the solar cycle. But everyone thought it was going down, and it turned around and it went up again. So the sun's fairly active. That's the latest image I can get hold of the sun. It'll be 8.5 old now. And count the sunspot numbers, they count the spots, the number of spots and the number of groups in the areas. There's a formula they use to get what they call a sunspot number. And you get daily sunspot numbers, which is all the jaggedy lines up and down there. And they convert to monthly sunspot numbers. The gradual spot here because this graph actually covers January 94 onwards. They have a daily sunspot number, which of course varies. A monthly sunspot number, which is that sort of averaged out, and that can be smoothed to get the blue curve there. It was peaked about January 2001, January, February. It went down again, and then it came up again. As you can see, there's very good evidence there of a double peak in the sunspot maximum. It started some people just scratching their heads and thinking, looking back, and when they analysed some data back from earlier years, it's not the first time it's happened. So the prediction was to follow the red line down, and the number was bouncing somewhere between the two black lines at the side of it, but I'm not too sure what's going to happen yet. But we suspect, and this is what all talk is now, that the activity will now start declining. And this time next year, so basically forget about seeing auroras from the latitude of Melbourne until the next sunspot maximum in about 10 years' time. And that's that.
Thank you, Roger. Ian, do you want to do yours next, followed by Bob? Getting that set up, I'll actually remind you that daylight savings comes to an end on March 31st, so not this Saturday but next Saturday. And also tomorrow at 5 a.m. in the morning is the autumn equinox, which is the time when the sun rises due east and sets due west, and day and night are the same length. It's a bit of trivia, as you're probably, most of you, sleeping through it. Also a reminder that NASA, the National Australian Convention of Amateur Astronomers, is being held in Adelaide from March 29 to April 1st, in other words over Easter, and they still have some spots left if people are interested in going along to that. Basically it's a once every 2 year get together of amateur astronomers of all sorts of levels of experience, from very experienced down to first timers. So if you are interested in that, do come and see me afterwards and we can give you some details. Okay, Ian, you ready to rock?
Yes, well, I'm going to NASA, so is Peter Lowe, and I don't know any others. Do you know any others who are going?
No. We're both giving papers too.
Yes, yes, but I haven't heard of anybody else, but nevertheless, you always find someone that makes it to the harbour. So I have to present also 10 minutes about the Antarctic eclipse, which will occur in November of next year. So that's what I'm doing now. This is a rehearsal for that. There have been some people who are interested in the eclipse the end of this year, in December, which is going to be in South Australia in Ceduna. What will happen, I think we should do soon after Easter and another meeting, is to have a bit of a session on that for those people who are interested. We can discuss as to how that's presented by a number of people or whatever. So as you know, you've got the facts about that eclipse you might be interested in. You can go there physically on the ground, go to Ceduna in South Australia and see a total solar eclipse. The first one for 27 years, 25, 26 years, and the next one won't be till 2012. So there's another 10 years. So you've got to live it 10 years longer to see one. If you miss this next one, it's Ceduna. And the one in 2012 will be in Cairns. So you can combine that with a barrier reef trip. The one next year, one this year will be December the 4th. December the 4th. And as you possibly know or will learn, the eclipse year is less than the ordinary solar year by about a month. No, not a month. Nearly 20 days. No, it's not a month. 20 days. So the eclipse season will get earlier each year. So there is an eclipse. The eclipse in 2003 will be on November 24th. So things move earlier. That's the one I'm just about to talk about right now. Now this eclipse, I need to put it on. This eclipse, as you can see, will be in a very awkward place in Antarctica. And not the sort of place that you can drive your car to. The only way that people who save their pennies can get to it is by an eclipse flight. And the reason for the eclipse flight is that for some years Qantas have been flying to Antarctica for sightseeing. Something like 20,000 people have been to Antarctica and seen it by air in the last 10 years. So they usually start in December and go December, January, which of course is the southern summertime. It means going another week earlier for November 24th, and you can see the Antarctic and an eclipse, a total solar eclipse combined. The only thing is there will be a lot more people wanting to go on that particular flight, and only those people sitting on the left-hand side of the aircraft and who have a window seat will probably be the only ones who will actually see the eclipse. So, nevertheless, undaunted, it's on, and there's the. I think we had some lights off. It might be easier to see. These maps are going to be pretty. Right, so you can see the situation of the eclipse here, curling around. Like most eclipses, it begins at sunrise and ends at sunset, as you can see there, sunrise, sunset. The pole is situated over here, and the pole is just about there. The pole's there, right? The pole's about there. And you can see Australia, see Melbourne and Perth. And that eclipse, Melbourne we'll know about it in Melbourne. We'll get 40% eclipse. The sun will be 40% covered. As you can see in Perth will be 60% covered. It'll be about 9 o'clock in the morning there, and it'll be a bit earlier in Antarctic. The aircraft will come in and not view really until it gets to the coast. And it'll follow fairly well due south. Due south, follow the eclipse as far as it goes. And I'll show you the next one. There's Antarctica. The place that it actually comes ashore will be a place called Mercury, is a Russian base there. It's in between actually. There's the 3 Australian bases, Casey, Davis and Mawson. Comes in, goes around and goes out. There's an Indian base there called Mercury and a Russian base very close to it. So it's coming in like this and going across. However, the only bit that would be seen on this flight would be this sort of area here. Incidentally, this is the Ross Sea. This is where Scott left for his ill-fated expedition in 1912, and Amundsen left somewhere around about here, or it might have even been there somewhere else to find that out exactly. However, that's of course a faster way into the pole, and those of people who have been to the IMAX theatre in recent times, there was an excellent program about Shackleton and his expedition where he came out alive and brought all his men out alive. That was in the Weddell Sea. The ship broke up here and was carried in the pack ice this way, and they sailed in their lifeboats up to Elephant Island, and then one of the boats actually managed to sail to South Georgia, which is up here. So they got out of it in this area. Incidentally, when you see Antarctica, that peninsula here lines up with South America. Bear that in mind when you're looking at a map of Antarctica, you know where you are. This way is South America, and this way is Australia, the other way over here. And it was pointed out to me recently by a speaker who's been there that the Andes in South America come down and the chain of mountains actually keeps on going into Antarctica. Another interesting fact is that Antarctica is in fact bigger in area than Australia. It's something like 1.7 times bigger, which I was quite astounded to learn. The other thing is there's the maximum. The maximum is there. There's Casey base, there's Casey. It goes in like so. There's the maximum there, marked in red, might be all that easy to see. Maximum is here, not far in from the coast. It's quite probable that the aircraft will not actually reach the maximum. The maximum is nearly 2 minutes of totality, but because you're an aircraft moving with the shadow, you probably might get another half minute or something like that. That's the advantage of being in an aircraft. Two advantages. One is you're above the cloud, and the second one, if you're flying with the shadow, you'll always get more totality than you'll get on the ground. Of course, the downside is you've got to look through an aircraft window, and you might have to shove someone else out of the way. Right, I've got another one here. That one here shows the greatest eclipse there. Here's your sunrise, sunset going across Antarctica, and as you can see it moves around like across. You're covering an awful lot of longitude because the lines of longitude are getting very close, but it's most of the places along here you're dealing with nearly 2 minutes of totality all the way along. It's not a situation whereby it doubles or trebles along its path like most eclipses. We're up there in the temperate regions. And the sun will be about 15 degrees at maximum in the sky, that's elevation. It'll probably not be quite that much when you get to the probably not quite that much when you get to where is it? The eclipse. At the maximum, 15 degrees, and the latitude is 72 degrees south. Now at 72 degrees south, as we know, we're all amateur astronomers, we know that the south celestial pole will be 72 degrees up elevation. That's not sitting very flat. If that's so, then there's the celestial equator will be at 90 degrees to the pole, and it'll be 18 degrees in the north. Now, the midday sun will be lined up, this is lined up in the plane of the meridian. The midday sun, 20 degrees south, so it'll be up there, it'll be 38 degrees. So the sun will be 38 degrees up at midday when you're 72 degrees south on that day. At midnight, the sun will make it 2 degrees above the horizon. So we've got a midnight sun. And I was also amazed to learn about Antarctica is the fact that the Antarctic Circle, which is the 66.5 degrees latitude line, actually cuts across some of Antarctica. So you can be on the Antarctic continent, particularly that peninsula bit that sticks out, and a bit on the other side, which I can point out briefly again, is in fact here. This bit here is above the Antarctic Circle, so you don't get the midnight sun, and a bit round here you miss out. So it's possible to be on the continent itself and not have the midnight sun. However, if you want a flight, you've got to book into Croydon Travel and pay a deposit, and you're talking about $2,000 or $3,000. But there was also, I saw an ad in the Sky and Telescope that said you can sail on a Russian icebreaker. So I looked that up on the net, and I saw a figure, a price for sailing on a Russian icebreaker for a month. And it was something like $3,199. And I thought, gosh, that's not bad, that's quite cheap. I realised that was deposit. 10% deposit. You see the prices? US. The cheapest seems to be about 25 grand, and the dearest is about 32. Yes, 32,000, so there you are. So you can do it a lot more expensive than flying if you've got the money. That ship will travel across the Indian Ocean and go to Crozet Island, Kangaroo Island, Hurt Island, and also stop at several of the bases in the Antarctic. They're going to try and see a lunar eclipse, but I don't think they'll do very well there. It's only a penumbral eclipse. And they'll also they will see the eclipse, the total eclipse, if of course the sky's clearer. And they've got the problems with the cloud.
Are they Russian ships? Russian ships?
A Russian ship, yes, a Russian ship. But they are charging American prices. Thank you.
Thanks again. Bob, you want to come on? Who's got the raffle at the moment? Who has the raffle at the moment?
I thought I was going to get Bill.
Good evening, ladies and gentlemen. For the newer people, I usually show about 5 computer simulations of the planet paths for the next month. So this is the one you won't see because that's the sun. It's the western sky, but basically it's showing that Mercury and Venus are basically out of action because they are in the sun's glare. It doesn't really matter much whether I pitched it at the western horizon for an evening sky. It's the same in the morning sky. Thankfully, as far as the Earth is concerned, they don't change their position for the morning sky. So Venus and Mercury are out for about a month. You can see Venus is still fluttering down, about to do a turn, to eventually go probably into the morning sky. It's sort of fairly obvious. Mercury is just marking time and doing nothing except following the horizon. We have residues of Venus here, but may I make the point, this is an early dusk sky. Early, okay, it's not very dark. Don't let the black background fool you, it's not dark. Mars is still a goer, but it's going down very, very low, and tonight, for example, it will be very, very close to the horizon in a dark sky. Saturn is also starting to decline, but it's still a bit of a goer. It's racing up to meet Mars there. And again, Saturn, same scenario. I mean, they're basically moving to the same part of the sky, so I can't sort of miss having them all. Jupiter's still good. Tonight, 20th of the 3rd, a moon was very close to Saturn. That's not an occultation. I just can't get the images down small enough to show that there is a bit of a gap. Jupiter's got the moon belting across it. I think on the 23rd of the 3rd, a moon's close to Jupiter. But basically Saturn and Jupiter are still good, with Jupiter having the upper hand because Saturn's declining. Okay. We still have a beautiful northern sky, but I've shifted it to the northwest because it's the only way we're going to capture Saturn. Now, Saturn it's here for the 2nd of April, middle of the viewing period. Saturn will be a little bit higher for tonight, and it will still be visible 9 p.m. near the next month. 2 stars that will help you identify Saturn if it's above the horizon. There's our Aldebaran there, nice and bright. The colour should be a bit brighter, but the colour is a little bit different as on the screen. Elnath there, so Saturn forms a nice scalene triangle with Aldebaran in Taurus and Elnath in Auriga. You hardly see the constellation of Auriga because it's just too low. There are nice clusters there, but you don't have much of a chance of seeing them. So there's good old Saturn. Jupiter, the brightest stars near to it are Castor and Pollux. Don't know the name of that one, but there's a yellow star to the right of it. Jupiter is supposed to be a bit circular there. That's not my mistake there. Okay, the rest of it says last month. There are stacks of objects in the sky and they're all easy. When I do a little magnification thing, I've picked out 3 objects that are worthwhile. I'll show you the Puppis area of M47, M46. Near the very lovely cluster Tor Canis Majoris, there's Canis Major there, it's Sirius. Just before I forget about the bright stars, you've got your Rigel there, Betelgeuse. I couldn't fit in the name for Betelgeuse because space comes at a premium. Canopus is actually starting to sneak into the northwestern sky because Carina is shifting over, so there's bright Canopus. Leo is about to move up into the northern sky. There's our Regulus. Okay, that's done. Anyway, it's on the charts. 3 objects. Okay, I'll show you that soon. There's a lovely double star just under Tor Majoris there that Perivelos pointed out to me, which I was aware of already anyway. But I'll mention that soon. And also, I'll show you the lovely M66 area. Okay, we'll leave that for a moment. Okay, southeastern sky. Not doing a lot here. I'll show you a close-up of the lovely spiral Galaxy M83. Again, there's Canopus, just sneaking it over again. There's a little bit of overlap. Achernar is descending, and we've got Scorpius coming up. I think the comet's, well, a week ago it was hanging around Scorpius. There's a lovely moon to cut out Antares. I think it's Antares behind there, not sure. Anyway, whatever. There's Libra. There's not many objects in Libra. Virgo is starting to move up. Absolute stacks of galaxies in Virgo with the bright star Spica. We've got our lovely galaxy there, in 104. That's about it. A good sky, but galaxies are starting to dominate. Omega Centauri, Centaurus A, etc., etc. And a few of the nice ones are descending there. Absolute stacks up in the Carina area, as David Giller had mentioned. You can really, really get lost up there. Okay, we exit from that. Show some of them a little bit magnified. Okay, northern sky. Now, Perry Velos wanted me to, I think, do this one. I was very aware of it, okay, back to Canis Major. We're near Sirius. There's M41. Okay, there's a line of Canis Major that we're familiar with. There's a line of stars, and that's Tor Canis Majoris. There's a variable there, UW. It's probably that blue one there, but I'm not really sure. Anyway, just a little bit down, there's the double, H3945, Canis Majoris, and that's a red star, and it's actually a double, magnitudes 4 and 6, and we'll blow it up. Okay, binoculars, and there we go, slight hint of blue in there, but it's imagination, the labelling's already showing. There's that tall Majoris cluster up there. We'll get serious and do a little bit more. Slight hint of the blue component. The primary is the ASV people say that the primary is an orange star with a hint of red in it, and the secondary is a lovely pale blue. And to finish that one off, we'll split it. So there it is. And of course you can see a shift because that's your telescope. I've spun it around. Okay, so, and that's with a small telescope. You should be able to see it because it's a 25.3 second separation, which is quite big. A small telescope should do that quite nicely. Okay, so that's Perry Velos's double that he wanted me to do indirectly. Okay, the open clusters. Yeah, where are we? For that. Rightio. We'll go straight to these. These are easy. Sirius and all that lot are around to the left. There's M47. I've left that as a... That's harder to do because the stars are very faint. But M47 is easy. Okay? The binocular objects, they're as easy as pie. So, two more to do. Northern sky, you can't miss these ones. These are a doozy. In Leo, the galaxies, the trio of galaxies. There's Deneboa, okay? Now between that red star and that white and red, we've got some galaxies. I'll show you those. They're easy to do. Okay, there's, see the line basically between those two stars. They're marked on the chart. Okay, 65, 66, they are easy. That's not so difficult. You can see a faint hint of it there. And if we blow it up, they spin around as I've told them to do. And you will see exactly that. And that's exactly how they appear in a sky and telescope photo, except there are more stars. But I haven't got a database going to magnitude 12. But that will be faint, and they're obvious. And they are as you see them in the sky. They are real. They look like that. Okay, one more object. Lucky last. Southern sky, there's only one. Rightio. I'll do a binocular thing on it. Oops. Okay, now that asterism is on the sky for the month. That's a simple asterism in Centaurus. All us observers know about it. It's very bright. It's very well known. If we hit that with a bit of magnification, it's blown up a little bit more. We still don't see the galaxy. The galaxy is there, okay? That's the asterism. And if we shoot up to it, you'll see it in a matter of moments. There's M83, okay, like I said. And if we blow it up finally, excitement plus. I haven't put the spirals in it. It is a spiral galaxy. I just didn't have time to link the spiral procedure with that. One can't do everything that one wants to do. All right, I'm done.
Right, as it's pretty much getting on for tea time, we'll draw the raffle, please, as you can. Just also a reminder while Dave's coming down with the raffle that if you haven't bought one of the almanacs, but the Society only has 2 left. So if you want one of these, see what's in the night sky, these are the last 2 for this year. If you do, come and see me afterwards or Don with the treasury.
Thanks for supporting the raffle again. 2 lovely books, Patrick Moore on Mars and Comets, Creators and Destroyers by famous David Levy. Normally I get someone to draw it, but I haven't got a good retainer this week, so I'll draw it myself, draw me a number, and we'll all be happy. And it's not my number, number 13, somewhere down the front I'd say. Number 13. And second prize, flip through the sticker, they're all falling out. Don't take the falling out one, that's mine. Number 40. Number 40. No one has 40. 40. There it is. Heinz? Well done. Thank you. Right, did anyone else wish to bring up anything before we break for tea?
Yes.
Yep, John.
I've still got a few more name tags for newer members, so if you've joined the society in the past several months or so and haven't got a name tag, come and see me over the break.
Also, I noticed the Lone Telescope is here. Is that available?
It's going out.
It's going out tonight. But if you're a new member and you might be interested in borrowing the Lone Telescope, see Ken. It may not be right away, obviously, but perhaps next month.
The month after.
Or the month after. Oh, okay. Right. Well, what we'll do now is we'll break for tea, which we'll be over in the kitchen area, and then we'll reconvene in here at 9:30. Okay, we'll reconvene in here at 9:30. For those of you who wish to hear me talk about the Cranberry Meteorites, and for those that wish to watch the video on Woomera and Rocketry, that will be around in the library room, also at 9:30. The video goes for about an hour, just under an hour. Okay, well at that we'll break the tea.
Excuse me, just before we go out, we can't go in the kitchen, alright? The tea is just out the door here.
I'll give it to you now. You give me a 3 minutes. Thanks.
Get it out. Yeah, I'll do that. I'll get a sundial. Thanks for that. Thank you very much.
Nothing was executed. Non-member will pay more.
Saturday or Sunday? Saturday or
some good news up at the Bryce.
Yeah, you don't have to get up there.
Certainly, I mean, I've looked at the buildings up there now.
well, they're carried around and
Yeah. Still gives good news.
Saturday or Sunday?
Doesn't matter.
Either way, that's fine.
When I've saved up enough, it's just
Yes, I do.
getting started, I think.
Once you get started.
Yeah.
Either Saturday or Sunday.
Yeah, it's fine. Not even a little bit of
No, which is possible now. They're saying that the Bryce might be a possibility. The thing about it is, I mean, the Bryce tends to be more available at night than day. If we can get a room size, yeah, it's fine. I mean, given a year or two down the track, I mean, ASF might have an exercise shed here for Bryce. We haven't got a sign.
Yeah, who has had a pattern of it.
I would be careful.
What's packing got to do with Bryce?
That's where he has his viewing remember of some astronomy society.
That's the Astronomy Society of Melbourne, probably.
Must be.
ASF, yeah.
And
And he doesn't go to Cranbourne, doesn't he?
he goes to Cousin Rabbit
Yeah.
about 2 weeks or something.
Yeah, no, that's the first I've heard of it, yeah. Well, I know the guy, I've never actually met him.
No, I went up to inquire about it. He just said he was
So I didn't see how he classes for 20 years. Took the classes. But that was someone else.
Two places.
And you don't get many assignments to go to see how he very yeah, you interested too or not?
Other than that, I would be interested in as well.
Yeah.
Definitely not Sundays, but Saturdays.
Saturday, yeah, okay. What's your name?
Simon.
Phone?
Probably work's about to change. Mobile 04.
Well, yeah, okay.
12 105 889.
Yeah, which one do you say?
Saturday's my preference.
Saturday, okay. That Saturday suits you, the day that most people want, yeah?
If I just buy those kits, then I can give you 45 cents. That makes a lot of sense. Thank you.
I'm assuming it'll be a handshake, honest deal, but yes, because those galaxies are, I like birds. I mean, huh? On a night of good transparency, you should get a faint but in fact, yeah, that's being honest.
You need a reasonably done.
Yes, you do. I mean, look, you could be
Probably not getting very forward.
and by the same token, you would see the better.
Ja, ik ken nog zo'n werk.
Because people eventually take the time, they turn up there.
I went along to that idea. I had this 30-inch telescope for 2 hours. Brand spanking new. Yeah.
Well, look,
I like to say is,
okay. Basically, go on.
is that the one of the ASF members from Shepparton? It's just gorgeous. The Obsession, is it?
No, he bought all the parts and just did it himself. The mirror cost him
Well, look, basically, it's been pretty heavy mirror object for 30 years now.
50 kilos.
Basically, you may have to stick to the order. I only pitched this that's going to be.
It's about 4.
Yeah.
But the sky must have been
I read it to you that
you took your...
it's a right channel.
Yeah, that's no, I mean, that's, oh yes, oh yeah, I'm sorry.
Oh, you went up to some Star Party? You went, did you? Yeah. And was clear weather? Yeah. Which I would have to go once every couple of years. Well, it's not. That's the impact.
Forget about it.
What's that one? Yeah. Don't worry about it, Mars one.
No, he didn't know. There's nothing like that.
I've been to that place. No, I haven't. That's such a wonderful
It wasn't the darkest place.
That's quite a cluster.
That was a brand new 30-inch.
Yeah.
I had that for 2 hours.
There's a very funny shot you might see that.
That's the Mars
It's brand new. You just can do a bit of woodwork. It was superb optics. I got to look through it for about 2 hours. When everyone, mainly there to create it was three-dimensional. And you can see all these dark nebulas over in front of all these other. It was just so clear. And the Veil Nebula, I went round the whole Veil Nebula, and it was like whispers, like tiny threads pulled out. You could see them winding around each other.
You might
Have a look at something like...
turn it off.
Yeah, we looked at it.
What was that like?
All right.
M42 is easy.
The globular clusters and
I'm sure you've
the triangular, it didn't look much different in mine. So
it's sort of
a big difference.
Four close stars with it? The 4 stars.
There was a big crowd around it all end of night, and I had to wait till 3 o'clock for everybody to go away.
You don't need to verify. M42. Don't worry about that one there.
Those are people the 2 nights. I was up for 5 years.
If you move,
It's the same time. This is shots up there in the sky.
within the handle,
Yeah,
that's what I was going to say.
How much darker would it have been on the prize?
when you see the pot of sky,
Next
Twice as dark,
rise,
it's still
you
not
get much better brightness.
Oh yeah, it does come through. From mixing things.
You get better brightness somehow. I don't know how to say that.
see rabbits running.
Oh, well, I've been down
Australia will get smaller and smaller. They will. We would like to see that.
I don't know if I should watch this or the other. Because meteors just the same thing.
One might be very interesting. I'm going to listen to this guy.
I think it was a lot of dust in the sky. Because it didn't have such a high situation. I was thinking the dust up, I think it was dust in the sky.
Because meteors are same
the observatories, the main one, walking down to that. So you see the slide.
Okay, this session is actually the Cranberry Meteorites.
Yeah, I think it's a waste of time if you've got skylights in that area. The equivalent to northwest would be over here, I think. Southeast,
Okay.
Right, well, this talks all about the Cranbourne Meteorites, and what I might do first of all is to set the scene, show you what Cranbourne was like around that time this is all starting. Some might say it hasn't changed very much since. But this is a picture of the main street of Mornington in the 1850s, and our story really begins around the 1850s or a bit before.
You see the moon.
Now the Cranberry Meteorites, there are about 12 or so of them. I say 12 or so because it's not known whether there are any others yet to be found, and there probably are others yet to be found. They're believed to have fallen sometime in the last 300 years, and in fact it's impossible to know precisely when they have actually fallen because the terrain that they fell into is extremely wet and swampy and very variable. Like certain times of the year it would dry out, other times it would become a quagmire. And so it's very difficult to date something that's in a changeable environment. So it's not as if it's wet all the time. You can say, look at how much it's rusted over that period of time. So the best estimate based on rusting is about the 1700s that the Cranberry Meteorites landed. But what I'll do is I'll switch to the slide projector now and show you some of the bits of rock and that are in the solar system, and then we'll come down to the meteorites, and then we'll go looking for where the next set of meteorites are going to be found. And one of the things that we'll be doing in the next year is trying to find some more. Okay, you want to turn it on again?
I just turned it on, I moved it one slide, but nothing's on the screen.
Can you turn the second switch on?
Hang on, maybe the internal.
That's the one. That's the one, that's the one. Now, our solar system began about 4.5 billion years ago, and here you see some lumps of rock starting to accrete from the silicate materials that were all in orbit around the proto-sun that was forming. And many of these clumped together to form the planets, the asteroids, and certainly out in the Oort cloud, where comets come from, way beyond the furthest reaches of the planets. Now, there are plenty of smaller bits and pieces still around in the solar system, and I'll show a picture of those a little bit later on. Some of the dust, asteroidal dust, that can be collected by high-flying aircraft, by NASA, for example. Now, some of the larger objects flying around the solar system have obviously collided into the planets, and for example here on the Moon you can see lots of examples where bits of rock from space have smashed into it and formed craters, and some of the craters obviously have mountains in the middle, and the mountains are formed in the middle because if you hit it with something with enough energy, it tends to liquefy that area and the middle bounces, and it's very much like here where you see a drop of water drops down into a bucket of water, it goes kaplop, and then it wells up in the middle. Exactly the same thing happens in some of the craters if there's sufficient energy. So in other words, the area around here becomes essentially molten, the rock bounces back up, but then solidifies in that shape, and that's why you saw some of those craters with the peak in the middle. So if you're looking at the Moon through a telescope and you see what looks like a mountain in the middle, in fact it is a mountain in the middle. Other objects in the solar system, like asteroid Gaspra here, photographed by the Galileo spacecraft, have again plenty of craters over them from impacts of objects relatively small. And we'll come back to the asteroids in a little while time. Now, other objects have been seen crashing into things in the solar system. For example, here, what you're seeing is a time-lapse photograph of a comet, which essentially is just a big lump of rock like Gaspra, the asteroid that you just saw, except that it still has a lot of volatile gases in it, and this is a time-lapse photograph showing it colliding into the sun, taken by, I think it's probably the Sullivan observatory, and there you see the last couple of moments as it smashes to pieces in the sun. Of course, a few years ago, I think back around 1994, 1995, my memory serves me correctly, there was the famous comet Shoemaker-Levy 9 that again was a lump of rock like one of the asteroids, came a bit too close to Jupiter. Jupiter's gravity tore it into about 21 pieces. Those 21 pieces proceeded to go around the Sun, and next time round then collided into Jupiter. And some of those were readily visible even in amateur telescopes. But again, these are lumps of rock getting on for the size of the one that killed the dinosaurs. In other words, they were up to 4, 5, even 10 kilometres across. So in fact, with Comet Shoemaker-Levy 9, each of those ones was about the size of a mountain. Now, at about the same time when Shoemaker-Levy 9 was found, they looked back at records on Callisto, and this is part of a map of the surface of Callisto, the fourth moon out from Jupiter, and you actually see a ring of craters here, sorry, a string of craters in a line. And obviously something like Shoemaker-Levy 9 has occurred in the past. Jupiter's torn it to pieces, and then each of those pieces has proceeded to go bang, 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 bang across the surface and left a telltale line of craters. But again, relatively large bits of rock. Now, one of those bits of rock struck the Earth 65 million years ago and left this layer of black stuff there. You can see there, it's about the thickness of a 20-cent coin and contains a lot of a very rare heavy element called iridium, a metallic element. Most of the iridium in the Earth is actually sunk to the centre of the Earth, so it's extremely rare on the Earth's surface, but in meteorites and asteroids it's quite common. So what happened here, 65 million years ago below the surface, something collided with the Earth and deposited a lot of iridium all over the surface, and hence when the dinosaurs were wiped out, in other words there were dinosaur fossils below that point but no dinosaur fossils above it, what happened was extraterrestrial cause, something the size of a mountain collided with the Earth, and that was bye-bye to the dinosaurs and about over 90% of all species on the planet.
Where is that, Peter?
I can't remember actually. I can't find the source. No, that's not Australia.
Yeah.
In fact, that layer of clay is actually found anywhere around the Earth that they look. So provided
America.
yes, indeed. And in fact, I'm not sure which country this photograph was taken. I can't remember the source that I originally took it from. It's so many years ago now. And there's the dinosaurs. This is one we show at public viewing nights, showing the last 10 seconds warning that the dinosaurs had. As a piece of rock the size of Mount Everest basically came into the Earth's atmosphere and ploughed into where the Caribbean Sea is today. And if you're interested in finding out how they died, come along to a public viewing night and I'll tell you there. Now, there are other ones visible from Earth where large lumps of rock, a bit smaller than the dinosaur killer, have occurred in the past. This one was before the dinosaurs, around 210 million years ago, and this is in near Quebec in Canada, and it's a large crater known as the Manicouagan crater, which is about 70 kilometres across. The one that killed the dinosaurs left a crater of about 200 kilometres diameter. So even though the rock was only 10 kilometres diameter, it left a crater 200 kilometres diameter. This one's a bit smaller and fills with water, as you can see there. Can they live in a really bigger print as well, that size? Entirely possible, yes. Closer to home, this one was only a few decades ago. A piece of rock probably about the size of the one that wiped out Tunguska, and unfortunately I couldn't find a slide in time to show you Tunguska in 1908. That was in Siberia, where a piece of rock about 60 metres diameter, which is not really that large, 60 metres diameter actually ploughed into Siberia. In fact, it never actually reached the ground. It destructed about 10 kilometres above the ground and completely flattened 2,000 square kilometres of pine forest, completely stripped the trees bare beneath it, took all their branches off and absolutely everything. This one was the same size, but it skimmed across Earth's atmosphere, taken in a video. In other words, it was like someone picking up a stone and throwing it across the surface of a pond. And it went skip, 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 which is probably just as well, because otherwise the person taking this video wouldn't have existed for very much longer than what you see there. Now another more recent one, 1988. This is a smaller lump of rock coming from space. This one was believed to have been, I think, around 40 to 50 metres from memory. Came over Indonesia and was detected by one of the spy-type satellites that actually looks down on the Earth's surface to see if any nuclear blasts had occurred. And what you see on this graph here is the satellite looking down on the Earth over Indonesia, and then all of a sudden there was this enormous burst of energy, and then died out about 2 seconds later. And what that was a lump of rock about 40 metres diameter came in. And fortunately, again, for the people that saw it, and this one was actually seen by fishermen, it burst sufficiently high in the air that the shock wave didn't actually get down to the ground. So these things do occur from time to time. They would be pretty scary because they would glow like a second sun in the sky as they were occurring. But as you see, this one, only 2 seconds. So all over and done with pretty quickly. However, these things occur all over the world. Bits and pieces of rock, and this diagram shows, again, monitoring satellites looking for nuclear blasts. And in fact, these are not nuclear blasts, these are where asteroids have come in, and small asteroids, lumps of rock tens of metres across, have come in and hit the Earth ever since 1975 up to 1992.
You're calling these asteroids not meteors?
Yeah, it's a fine distinction. It's a lump of rock. When does an asteroid become a meteor or a meteorite if it lands to the surface or not? And in fact, I haven't been able to find a distinguishing point. There's a similar sort of greyness of area between what's a planet and what's an asteroid. For example, the old argument over is Pluto really an asteroid or is it a planet? Same sort of thing occurs with meteorites. And I think what tends to be, if an asteroid came in and survived, such that it was found on the ground, we would probably call it a meteorite rather than an asteroid. But this one here, you'll notice one was actually over Adelaide. And in fact, at the time that one came, Adelaide was under clouds, so they didn't actually see anything. Otherwise, they would have seen a second sun in the sky. And if it had been a little bit bigger, they wouldn't have seen much more. Ever again. So when something comes in from space, ploughs into the ground, irrespective of the size, provided it's over about 10 metres across, if it gets down to the ground it will form a large crater. You might get the mountain in the middle like we saw with the moon, and you get material piled on either side. Below about 10 metres, what tends to happen is it forms what's called a dug crater. In other words, it'll form a crater in the ground, but it'll be fairly shallow and only a few times larger than the object itself that came in. Now, when it comes to the Cranbourne Meteorites were believed to be about the size of a very large car or a truck in size, weighing around 10 tonnes of the stuff actually got down to the ground. So what came in from space would have been considerably larger than that. But it formed a dug crater. Now, here in Australia, 300,000 years ago, a piece of rock, certainly smaller than this room, ploughed into Western Australia, forming a very large crater there. But again, you would call something that size either a very small asteroid or a very large meteorite. This particular one disintegrated, and you can find bits and pieces of this meteorite sort of scattered around this side. It came in from that direction and has since actually filled up with sand from the desert. So the various scenarios, if you get tiny bits of stuff, about the size of grains of rice up to about the size of a pea coming in, they burn up very high in Earth's atmosphere. So on this graph here, going from ground level is 0 up to 120 kilometres above the ground. Meteors that you see, shooting stars as some people call them, are these small tiny bits of rock that come in, but they burn up from the friction and aerodynamic forces very high up above the ground. If they're a little bit larger, they might make it down to around the 30 to 40 kilometres above the ground before they destroy themselves. In the case of Tunguska, it got down to around 10 kilometres above the ground. If they're even larger still and made of really solid stuff, like solid nickel and iron, which indeed the Cranberry Meteorites are made, they can get to reach the ground level. And if they come in at a sufficient angle, they may slow down sufficiently that they break up into bits and pieces. And that's very important for the Cranbourne Meteorites because they are believed to have broken up like this and undergone a number of separations, as they're called. So in other words, the meteorite comes in, it gets down really deep in the atmosphere, but then the forces and pressures on it are so great that it's eventually sort of torn asunder. And as you see here, one bit is torn apart there, and then the rest keeps going, and then that's torn apart. And that scenario does actually occur with the Cranberry Meteorites. This poor lass here in 1992 had one fall on her car. This is a very famous meteorite, as it was videotaped very extensively in America, in New York. This is known as the Peekskill meteorite. As you see, it absolutely demolished the back of her Chevrolet Malibu, and she got very, very rich by selling this to a museum afterwards. So it might have been a bit of a beat-up car before, and certainly is a beat-up car now, but it was a very valuable car. And we'll also see a bit more of this meteorite later, because it will give us a clue to some of the behaviour that occurred to the Cranberry Meteorites. This young lad here had a meteorite come over him, probably not too different in size from the Cranberry Meteorites, maybe a bit smaller. And the bits and pieces that they found, as you can see down the bottom here, on the scale, I don't know if you can see it, but something about a handspan across is about 6 inches on this scale. So some of these large lumps down here on the left-hand side are getting on for about 1 foot in diameter. And if one of those fell out of the sky, you'd be in big trouble. But even these little ones can cause you lots of problems. And I like showing this one because it says here that this young boy had the distinction of being the first person known to have survived being hit on the head by an extraterrestrial. He was lucky because the bit that hit him only weighed about 3.6 grams from this meteorite, and it had the edge of its velocity taken off because it hit a banana plant leaf first and then bounced off, so he got the ricochet. And they said had he been one of the larger chunks in this lot below that they found later, he might not have remained in a position to recover the stone, is what the scientists said. So this particular guy was very, very lucky. That was in Uganda. Now, a few years ago, Comet Hyakutake graced our skies, and comets leave behind a trail of dust and debris. Now, meteorites, which are lumps of rock that actually survive to reaching the ground, are not believed to come from comets at all. The debris left behind in the tail of comets gives rise to meteors or shooting stars. In other words, it's only small bits and pieces. And this particular one, Hyakutake, photograph taken by Jim Blangsby, only is showing one tail there. If we look at an earlier one, Comet West, you can probably make two tails out. And one of those tails is basically gas, carbon monoxide type gas, and the other one is the little bits and pieces that if the Earth runs into it and they collide, that they burn up about 120 kilometres above the Earth's surface and give you meteors. So in other words, the Cranbourne Meteorite is not believed to have come from a comet as such. So here it shows a scenario of a comet goes around, and if Earth happens to run into the trail of debris left from its tail, then we get a meteor shower, much like the Leonids meteor shower that we all got to see in last year. And if you're in any doubt that there's debris coming from the back of a comet, this is the Giotto space probe, or a computer-generated image of what was believed to be its situation based on the sensors. In 1986, the European Space Agency flew this pretty close to the head of Halley's Comet, and it's got absolutely peppered by small lumps of rock essentially going through its initial blast shield at the front here. But again, nothing very, very large. This photograph of the Leonids, I think it probably is you probably see the Cycler Leo there. A couple of them coming straight at you. I think those two there. But again, only small bits of rock, nothing to worry about because they're about 100 kilometres up when you're actually seeing them burn up coming towards you. Smaller still, little bits and pieces left over from the formation of the solar system and maybe where bodies have collided together. This one here is only a couple of microns across, so millionths of a metre. So a microscope picture of some asteroidal dust. And this is falling on the Earth all the time. So it's not an unusual occurrence. NASA flies aircraft very, very high with sticky aerogel on it, and they can actually pick this stuff up from air as it slowly drifts from outer space into the Earth's gravitational field and is picked up and eventually deposits its way down. Now when a large body in the solar system is formed, what happens is all the rocks and bits and pieces of metals and everything come together under gravity. And initially it's fairly uniform throughout until the asteroid or the planet get to such a big enough size that the decay of uranium to thorium within it causes radioactive heating of it. And when that occurs, what happens is the size of the asteroid or the planet itself, if it's big enough, becomes molten. And when it becomes molten, all the heavy stuff, which are the metals like iridium, nickel and iron, sink to the middle, and all the light stuff floats to the top. Exactly the same happened with the Earth. When the Earth got to a certain size, 4 billion years ago, it was molten throughout. All the heavy stuff sunk to the middle, formed a core that's made mostly of nickel and iron, and all the light stuff, the rocks that we're standing on, floated to the top. Now why I tell you that is because occasionally asteroids tend to collide together, and large lumps of rock collide together. And if a collision occurs with such violence that it completely shatters the asteroid to bits, you get some bits coming off from the top where it's rocky, and other bits coming off from the centre of it where it's metallic. And if some of those bits happen to reach the Earth and then fall to the ground and are recovered as meteorites, some of the meteorites are going to be made of rock, some of them are going to be made of metal, and some of them are going to be in between. And in fact, what I'll do is I'll show you a couple of meteorites. If you turn this light projector off for a second, we'll go back in. Turn it off? Yep. This particular meteorite here is one that fell in Africa in the 1800s, and it's nickel iron. And you can probably tell right away by looking at it by the sheen and the shine all over it that it's quite a metallic body, and certainly a magnet will stick to this quite readily. And in fact, if you cut it open, what you find inside is something that's very, very characteristic of nickel iron meteorites. You see this funny sort of pattern. that's throughout it. If you etch it with nitric acid and then polish it up and then to stop it from rusting, if you find that inside, it's pretty much diagnostic that that came from the very core, the centre of an asteroid or a planetesimal. Because the only way known to form that with nickel iron is to have molten nickel iron in certain proportions and then slowly cool it down at a rate of about 2 to 3 degrees per million years. So in other words, you're cooling that metal down extremely slowly. So this meteorite here cooled down very, very slowly, and the only place that that can occur in the solar system, cooling it that slowly, is right in the middle of a large object like an asteroid where the heat can't get out. So in other words, it does cool down very slowly, and also it has to cool down in zero gravity. If there's any gravity, you won't get these striations on it. And in fact, the proper name of it is a Widman-Staffen structure, and the Cranbourne Meteorite is actually exactly the same as this one. Here's another meteorite here, but this particular one is not metallic, as you can see. This one is from, I think this one was actually from Henbury. And as you see, this one is one of the rocky ones. So that would have come from the bit of the asteroid that was further up, higher to the surface. So the Cranbourne Meteorites, which are very similar to the one that I showed you before, the one with the structure here, came from the centre of an asteroid. Now, which asteroid it was is anybody's guess, or rather it doesn't exist anymore. Alright, if I can have the slide projector back on here. Now, most of the meteorites and large lumps of rock that come out of the sky can be plotted on a graph over time, and this is a log-log plot. Don't worry about what that means. It just means big stuff is over on the right, and very often stuff is up the top here. So this says very, very frequently the Earth is hit by dust, which is only fractions of millimetres. However, occasionally you'll get something the size of a bag of sugar that might actually hit the Earth a few times every year. Then you might get something the size of a truck, about a tonne in size, that hits every tens or tens of thousands of years. And indeed the Cranberry Meteorites sort of come at that frequency there, where we could reasonably expect one of those to be hitting the Earth once every, certainly a few times every million years. And occasionally you get something the size of a battleship hit the Earth and causes craters like Wolf Creek crater and the Manakougan crater that we saw a little bit earlier. Another picture here showing the different types of meteorites. Basically there are the stony ones, like I showed you an example of before, the iron ones like Cranbourne, and the ones in between, where the asteroid hadn't yet quite differentiated between the two, and it was still really a mixture of iron and stones. Now, only 3 meteorites to date have been proven to have come from the asteroid belt, as they were photographed or videotaped on the way down. There was the Pribom one, which is from Czechoslovakia, and that's the orbit of it compared to the Sun in the middle, Mercury, Venus, Earth, Mars and Jupiter's orbits, shown there in black. There was the Innisfree, which was from Canada, and the Lost City meteorite from America. And as you can see, when they calculated the orbits based upon the photographic evidence of seeing the thing coming in, it struck the Earth at these points in Earth's orbit, but when they worked backwards, you see all of these orbits go out to between Jupiter and Mars, in other words, where the asteroid belt is. So almost certainly the Cranberry meteorites would have come from a similar source as well. Now, another way of trying to find more exactly where meteorites come from is to try and match up their reflectance spectra. Now, what that means is you cut the meteorite in half and you shine a light off it, and depending on the minerals inside it and the amounts of each of the minerals, it reflects different coloured light in different ways. And this is showing like different colours of light across the bottom versus how much of that light it shines away. And the shape of this varies from meteorite to meteorite. And scientists can actually measure this also for the asteroids out in the asteroid belt. And here you see the measurements for the asteroid belt are shown as the circles, and the ones for a meteorite are actually shown as the solid line. And you can see here, for example, that the asteroid 176 Iduna matches pretty well with this particular meteorite that was discovered. And same with these other ones. Doesn't necessarily mean it came from that precise asteroid, but it came from that family of asteroids that were formed around the same time. And as you see, they're pretty diagnostic from each of the different types of families of meteorite. Now, when a meteorite is travelling through the solar system, Sun in the middle, Earth in orbit around it, almost all of the meteorites are going to be, and other bodies in the solar system are going to be travelling in the same direction. In this sort of orientation, it's anti-clockwise. And we have the Earth over here travelling also in that direction. Now, as you can see, if the lump of rock happens by chance to be coming in the opposite direction, it's going to run into Earth at very high velocity because Earth is going upwards. So it will run into Earth at about 70 kilometres a second, say, and completely disintegrate. We'll never get down to ground level. However, if it's coming from behind, it stands a better chance of actually getting down to the ground because Earth is trying to pull away from it, and so the relative speed of impact is going to be a lot less. So almost certainly when the Cranbourne meteorites, the mere fact that they even reach the ground means, number one, they're very solid, they're made of nickel iron metal, but also they must have come from behind the Earth as well. You're also more likely to get meteorites landing between this point of the Earth and that point there, because again, the spin of the Earth is trying to outrun the meteorite. So again, the relative speed upon impact when this thing does run into the Earth is less there than if it's on this side of the Earth where the Earth is spinning against it. Right, now we come to the moment 300 years ago as the meteorite is coming in, about the size of a truck. Now, all of the Mornington Peninsula, almost all of it, looked a bit like that before white man actually came to the area. This, for those that live in Seaford, is actually the Seaford Swamp from Austin's Road. And most of the Mornington Peninsula in the historical records was essentially meant to be a mosquito-ridden, impassable swamp. And it's hard to believe when you actually travel around the Mornington Peninsula that a lot of it looked like that. And in fact, it was so bad that at certain times of the year, even after they had built roads initially in the 1800s, middle of 1800s, that you just couldn't get through. And there were stories of clergy being actually going out one day to preach to homesteads and never coming back again. They never found them. And it's believed they sort of sunk in the swamp and disappeared. Now, at the time when the Cranberry meteorites came down, all of the Mornington Peninsula was populated with the Bunurong tribe of Aboriginals. In fact, the Bunurong consisted of many sub-tribes, and they were actually cannibals. In other words, they warred amongst themselves quite a lot, and you wouldn't want to be one of the losers of a fight between one of the sub-tribes because they used to eat each other as a result. And in fact, the records actually show they liked particularly eating the kidney fats of the people that they defeated in battle. So they didn't necessarily even kill them. And here's a map that shows you all the Aboriginal tribal areas at the time. Certainly when this map was put together in the 1870s, you can see there's the giant Cooley-Rupp swamp. Originally when when white man first came to the area, these swamps stretched right the way across here. And it was only through concerted draining of the swamps over almost half a century that they reclaimed all of this land here. And in fact, the only reason that this part of the Melbourne area was opened up was to act as a breadbasket for the goldfields. So all this area started to be opened up around the 1850s. The idea was to open it up for dairying and food production so that you could feed all the miners up here at Ballarat. And in fact, you can see a couple of the meteorite falls there. Then white man came to the area. And it wasn't until 1868 that Cranbourne actually came into existence. Now, at the time, of course, it wasn't Victoria, it was the colony of Port Phillip. And you can see here on the logo of Cranbourne at the time of its formation, cows and crops, and a bit of industry over here. In other words, it's reflecting the entire purpose of Cranbourne was actually to act as a breadbasket. Now, the Cranberry Meteorites themselves, what I might do is show you an overhead slide, if you want to turn that down, Ian. Cranberry Meteorites themselves, the exact number is not, even the exact number known is not really known for sure, because there was a mineral dealer by the name of Abel, who was actually the assayer of Ballarat at the same time. He had lots of little bits of meteorite that he labelled as Yarra Yarra River fragments. However, the Museum of Victoria actually lists them as part of the Cranberry Meteorites because their composition is so similar to the Cranberry Meteorites. And here you can see from number 1 down to number 12, each of the falls that came. In other words, this large lump of nickel iron came into the Earth's atmosphere, broke into around a dozen pieces or more, and over a distance of about 24 kilometres, peppered itself across the landscape here in Victoria. And some of them are actually given names, like the first one that fell, weighing about 3.5 tonnes, was called the Bruce Mass. And they called it Bruce because that was the name of the guy that ended up owning it. Not initially, but the one that ended up owning it and then donating it to a museum. Another one's called the Abel Mass, another one Pakenham, Beaconsfield and Pearsdale. So the last three were actually named from the place where they were found, and I'll show you a bit more of that afterwards. You'll also notice that there's no rhyme or reason as to the numbering of the meteorites. So they call that one number 1, but it wasn't actually the first one found. The first meteorite found was actually number 2. And the third one found was in fact number 3, so they were consistent there. However, these other ones are in all sorts of different orders, as you'll see with the discovery date down there. Like number 9 was discovered in 1876, yet number 8 was discovered in 1923. I haven't actually been able to find a reason other than just pure mistakes along the way, and they just didn't want to go back and recorrect their records. And most of these are scattered around the world, and there's quite a story behind it, and I'll tell you a bit about that in a moment. The biggest one sits in the Natural History Museum in London, in South Kensington, and I'll show you a photograph of that shortly. National Museum of Victoria actually has some of the other ones. It certainly has the Abel Mass, number 2. After quite a bit of public furore in the 1850s and early 1860s. And some of these other ones, like number 9, were basically bought by mineral dealers and cut up into little bits and sold, which was a great shame. Cranbourne meteorites are actually one of the best documented in the world. Now, the government officials, to their credit at the time, and the Royal Society, absolutely classified these quite nicely. They didn't get the numbering very well, but they did record the location of them before people came in and took them all away. So the exact locations of where they fell to Earth are actually known quite well, and also the dates at which they landed. Now, the story of the Cranberry Meteorites is quite complicated and far too hard for me to remember, so what I'll do is I'll use this as a bit of a cheat sheet. Right, so around 1700s they came in and landed in the swamp. Now, it would have formed a dug crater, in other words only a relatively small crater, and because it's in swampy ground, craters tend either not to exist at all or they're filled in very, very quickly. So in other words, there's no craters to actually go out into Cranbourne and have a look around. Indeed, even the swampy area that they landed in would have been well and truly reclaimed and dried out by now. Now, Cranberry Meteorite, or what became Cranberry Meteorite number 1, was known by the Bunurong because they used to perform fertility rituals around it, because it used to have a whopping great spur of nickel iron sticking out of it that apparently looked a bit like a phallus. And they used to strike it with something hard and it would ring like a bell. So they realised that it was something special, and it also formed part of their tribal stories. So the Aboriginals possibly even saw it coming in or heard it coming in, the sonic booms as it came down. 1852, really everything was opened up for the goldfields, trying to provide food, sufficient food, thinking longer term. 1853, the white man comes along. One of the stockmen passing through that area of Cranbourne actually decides to tether his horse to what he thought was a tree stump. And when he tethered it to what he thought was a tree stump, suddenly realised that it was metallic in nature. In other words, oh, there's a great big lump of metal here. Now that's at a place called Devon Meadows. Even at this stage they didn't know it was a meteorite. They thought it was a natural metallic outcrop of iron. Now shortly afterwards in the same year, this is all getting on for the end of 1853, a second outcrop was found about 5 miles away. And lo and behold, what you might think is, oh, there's a big iron deposit here, and I know the iron deposit's underground and it goes for at least 5 miles because I found 2 of the outcrops sticking above the ground. Or so they believed. Now in 1854, a local blacksmith by the name of James Nelson, I'll show you a photograph of him in a little while, decided to chisel a great lump out of the spur of number 1 and chopped out a section of it, which is no mean feat considering it's a great lump of nickel iron, and it's like asking someone to go and chisel a lump out of an anvil, right? So it's really, really solid stuff. Chiselled something out about that size, a lump of iron about that size, proceeds to make 2 horseshoes out of it and a lump about the size of a fist. So absolutely desecrates the Aboriginal thing that they danced around, and showed it at the Great Melbourne Exhibition of 1854 as a sample of iron from Westernport. Didn't know it was a meteorite, it was just believed to be a sample of iron from Westernport, so perhaps there was something other than dairying that Cranbourne could offer. So at that stage the world suddenly realised, oh, there's iron down there as well. Now at that point, for about 3 years, nothing more happens. Okay, there's some iron just being found at Cranbourne, and then in 1857 a farmhand, actually on the same property that number 1 fell on, discovers another meteorite. This one's only fairly small, about 15 kilos, and he thought at first that it was a great lump of gold because when he picked it up it weighed so much, and nickel iron is really, really heavy. And something that's 15 kilos of it is quite compact, really. So initially he thought it was gold, and then saw the error of his ways afterwards. And they used it as an andiron in a fire. In other words, they used it as like a rest for putting logs on a fire. So that's where Cranberry Meteorite number 3 spent the next 3 years in a fire. It split in half during that period of time, and one half was thrown away, unfortunately. So in 1860, what happened was a councillor in the Cranbourne area, it wasn't actually Cranbourne at that time, but in 1860 a Cranbourne councillor went to Melbourne, a conference in Melbourne that was trying to decide where to build the railway line down to the coalfields, down Cape Hatteras, down Gippsland Way, and they wanted to argue for the railway to come through Cranbourne. So being very enterprising, they went to the conference and argued, well, you know, we've got massive iron deposits down Cranbourne that extend at least 5 miles underground. If you bring the railway down to us, we then can take the iron out of the ground, take it up to the Port of Melbourne, and then we can export it, perhaps. Well, being a doubting Thomas, the Melbourne town clerk at the time decided to come down and actually investigate. And he was a bit cluey. He knew a bit, he was like an amateur enthusiast in geology, and he knew enough about geology to realise that there's no way that you're going to get an iron outcrop down at Cranbourne. And he identified the number 2 meteorite, and he identified it as a meteorite. And at that time, it was the largest meteorite in the world, and Cranbourne was world famous. We were the absolute toast of Europe society. And later on that year, number 1 was also identified as a meteorite, but number 1 was left in the ground. So in other words, they took number 2 out and they left number 1 behind, not realising what it was. Cranbourne was visited by the Emperor of Austria, came all the way out specifically to see the Cranbourne meteorites and also to stand on the landing spot where the meteorites had come in. So here we are, we had the Emperor of Austria. There were various lords and scientific dignitaries came out to Cranbourne just to stand on this spot of paddock halfway between Clyde and Berwick. So you're on very hallowed ground down there. Number 3 had now been identified. That was the one that was that was used as a bit of a log rest in a kitchen fire. And half of it had been thrown away by the owners of the household because it had broken in half. And the other half was then given away to somebody else. Now, the property owners, the people that owned the property where number 1 and number 2 fell on, thought this meteorite rock was a bit of a nuisance. They wanted to get back to more important things like growing stuff for the produce for sending up to the goldfields. So what they did was they offered it to the town clerk who had come down and said, well, if you want to pay for carting it away, you can have it. Well, he declined the offer and actually went back to the government and said, well, it's probably more appropriate that you take them away and then you can treat them as objects of scientific interest. Now, governments tend to move in very slow ways. And while they were waiting on the reply from the government as to whether they wanted to do it at the time, number 1 was then sold to the neighbour of the person whose property it was that it was on. And they actually bought it for £1, which I'm sure was a fairly princely sum in the year 1860. And they bought it with the express intention of donating it to the British Empire, back to Mother England. And in fact, they bought it for £1, and it was said that he paid the sovereign so he could give it to the sovereign. Now, 1861, next year comes along. Again, still waiting for the government to make up its mind whether it wants these 2 meteorites or not. Biggest in the world. Everyone wants it, but the government can't make up its mind. The owner of number 2 gets impatient and sells it to a mineral dealer. Now, the mineral dealer then sells it also to the British Museum. So we have number 1 and number 2 destined for leaving the shores to England. Number 2 is actually dug up and transported back to Melbourne and shown in the Melbourne exhibition and then shipped off to London and shown in an international exhibition over in London, and then it stays there. Number 1, by the way, is still in the ground. Another year ticks by. Number 1 is still here, and the Royal Society is starting to get a bit worried that it's going to be sent back to England. And they propose, or rather they lobby the owner of number 1, and they come to an agreement that they're going to cut number 1 in half. Half of it will go to England, and half of it will stay at the Museum of Victoria. Again, while they were waiting on a reply as to whether they want, number 1 was dug up and carted off to Melbourne with the intention of sending it off to London. Now at this stage there was a massive public outcry in the newspapers saying we want our rocks back. And number 2, remember, is already over in London, and number 1 is destined for London. Now there was such a public outcry that there was a government commission into who really owns these rocks. Is it the property owner where they landed on? Is it the state government? Is it the local council? Or who is it? And there was so much public outcry on it that it was another 3 years before much happened. 3 years later, 1865, the Royal Society convinces the British Museum to give back number 2 on the condition that Victoria relinquishes number 1 intact. So rather than cut number 1 in half and ruin it, they made this deal whereby you send us back the one we've already given you and we'll give you back the biggest one. So the biggest one is sitting in London, where it still is today. And eventually they did actually return number 2 back, but only after they got number 1. 1868, Cranbourne came into existence. 1876, number 9 was found in a railway cutting. And in fact, most of the other Cranbourne meteorites are found where the ground has been disturbed in some way. So while they were building the railway through to Sale, they came across number 9, just below the surface, or actually on the surface, that one. Now, unfortunately, that one was bought by a German mineral dealer who cut it up into bits and pieces and made a fortune selling it overseas, and that one is dispersed. One of our members, I think, actually has one, and I thought he was going to be here tonight, but he wasn't. And he does have a bit of the Cranberry Meteorite. 1886, 10 years later, number 10 is actually found in Pearsdown, when a farmer is ploughing the farm. In other words, it was just below the surface, and he did the right thing and donated it to the Museum of Victoria. Then a big gap till 1903, and then number 11 meteorite was found near Langwarrin railway station, just below the surface, and that was sold to an American museum by the owner of the property. 1923, 4 meteorites were found, numbers 4, 5, 7 and 8, in paddocks near number 1. In other words, the big one, the 3.5 tonne one, they searched the paddocks properly, and they found another 4, again while ploughing the paddocks. And they all either sit in Victorian museums or various university geology departments. So all of those are within Victoria. In 1927, a 12th one was found, but it was kept secret. No one was told about it other than within the family. Number 1928, the number 6 meteorite was found when the Princes Highway was being widened during earth-moving works. They discovered it somewhere in the first metre of soil that they removed, and that also sits in a Victorian museum. And in 1982, the one that was kept secret in 1927 actually came to light. I suspect there that it was probably a case of, it was a family heirloom, or became a family heirloom. The family member potentially who found it originally had died, passed on to the next generation. They thought, oh, what's this rock? And if they had enough sense, they probably showed it to the museum, and then the museum probably convinced them to donate it. It's now, strictly speaking, owned by the Museum of Victoria, who have it on permanent long-term loan to the Cranbourne Shire, and you can actually go and see number 12 in their offices. I might have the slide projector back on here, if possible. This is where number 1 fell. As you can see, even today, it's fairly swampy ground here, certainly not as swampy as what it was in the 1850s. And you can see the sort of the bird life around here is very much as you would expect for swamps. Number 1, when it was dug up, was obviously a bit smaller than this. This is an American one, but you get the idea of what it would have been like around that period, digging up the ocean.
I think that previous one you just showed, that big one there, I think that's Southwest Africa.
Correct, it is the Woomera.
Yeah.
Yes. Yep. The blacksmith who cut the lumps out of number 1 is James Nelson, shown here. He was the only blacksmith in Cranbourne, and he was responsible for building the ironwork in the Prince's Bridge up in Melbourne as well. He also was an amateur astronomer and very well read in astronomy. Now, number 1, again, this is not the Cranbourne Meteorite. Cranbourne Meteorite, the big one, would have been only about that size. Was dug up and moved by bullock cart, and this is an example of a contemporary bullock cart used. And just to move number 1 from Cranbourne to Melbourne on these bullock carts through the swampy conditions cost £50. So an absolute fortune in those days, just to move the rock from Cranbourne, just to get it up to Melbourne. Skip over that one. Now, the exhibition in London shows the Cranbourne meteorites here. And this is a section of it showing the Widman-Staton structure, exactly as I showed you on that other meteorite before. And there it is, pride of place in their meteorite collection on the top floor of the museum, right next to their moon rocks, which are over on this side of the room. And it's actually stored under dry nitrogen, because if they store it in the open air, it tends to rust. So a very large lump of nickel iron, that's number 1 meteorite, the biggest one that fell. Number 2 fell here, and this is what it looks like today. Again, just open paddocks. And you can just imagine going over this with a metal detector, try and find another meteorite. Metal detectors, incidentally, haven't been used to date to attempt to find any more. Here's number 2 in the Museum of Victoria.
That number 2, is that the one that's down at Science Works? That's the one that's
Correct, yeah. They moved that one down to Science Works. Museum of Victoria also has number 4, and I don't think that one's on public show at the new museum. It used to be at the old museum in Swanson Street, and again, a very large lump. They also had number 10 at the museum, but they seem to have misplaced it, which probably means that it's sitting away in their archive somewhere. Now down in Cams Road, you can see the replica of each of the Cranberry Meteorites. All it is really just fiberglass and chicken wire frame, but it's meant to be similar sizes. So there's number 1, there's number 2, going down through all the various lengths. It's been vandalised quite a bit since this time. Some of these have been ripped off their stand. It was built as something commemorative for the bicentennial. Is it from another angle? Just skip over that one. Right. Now the meteorites came in from this direction. So they came in over Pakenham Officer, and the first ones fell down there. So the first ones to fall were number 6 and number 9. They came down from a northeast down to a southeast direction, and deposited themselves where each of these circles are here. So as you can see, the last one to be found, number 12, is over in that direction. Now the reason they know it came in that direction, even though no one saw it, was because the larger ones tend to be downrange. Smaller ones tend to be uprange, larger ones are downrange, and I couldn't find any polystyrene balls to show you for tonight, but there would have been a demonstration that if I had a large polystyrene ball and a small polystyrene ball, throw them across the room, which one goes the furthest? Well, the large one will go the furthest. And exactly the same thing happens with the meteorites. The large ones, when they break apart, will go the furthest, and the smaller ones will drop down short. That's just a close-up showing Clyde, Devon Meadows, right down to Pearsdale. And there could be others in between. Show that one later. Now, in the case of meteorites, as I say, the big ones fall downrange. With the Hembury meteorite craters that some here did go to see when they went to the Leonids in Central Australia. The Hembury craters came from bottom left to top right. The meteorites came in and left a big crater downrange and lots of little craters uprange. So you get the idea that the smaller bits and pieces fall first. The Peekskill meteorite, this is the one that demolished that girl's car earlier, was videotaped as it came in. You can see the big pieces kept going and the small pieces fell short. So it's very convincing evidence that that is precisely what happens when these separations occur, when lumps of rock actually start peeling off the main body. There's the main one. Now in the case of the Cranbourne Meteorites, I've overlaid here what's known as the scatter ellipse, in other words showing that the path of the meteorite was, say, roughly along this line, and then it basically fell at various points along the line. Now what I'll do is I'll have that off, please, and I'll just go to overhead projector instead. It's getting very late. Now this table here tries to show from each of the locations going from north to south, northeast to south as the meteorite came across. It came at Pakenham first, then down to Clyde, Devon Meadows, Cranbourne South, Pearsdale. The fragments that fell around Cranbourne were number 6 and number 9, and the mass of them was 41 kilos and 75 kilos. In other words, the light one fell first, the heavy one fell second, so fits in with the theory so far. At Clyde, number 2 was very, very heavy, 1,500 kilos. Haven't found any light ones. So found the heavy one, but not the light one. At Devon Meadows, they found 5 meteorites, numbers 8, then 7, 5, 4, then 1. And again, in ascending order, the light one fell first, 24 kilos, 153 kilos, 356 kilos, 1,200 kilos, 3,500 kilos. So it fits the theory. Lighter ones, then the heavier ones. So in this case, the downrange heavier ones have been found, and the lighter ones, say 24 kilos, have been found. There could be others, but they just haven't been found. At Cranbourne South, which is pretty close to Devon Meadows, Only number 3 has been found, which is only 7 kilos, which is, well, I believe it was meant to have originally been about 15 kilos before it was broken in the fire. Again, a light one has been found, in other words, the uprange one, but nothing has been found downrange. And the final one at Pearsdale, along the flight path, it's number 12, then number 11, then number 10. And again, we find the light one, 23 kilos, then 2 very heavy ones, 760 kilos, 900 kilos have fallen. So in other words, the theory is holding that the light ones fall first, then the heavier ones occur. Now this is saying, in theory, that the Cranbourne Meteorite had 5 separation events, 5 times when it broke into pieces. Then the next one broke into pieces, and then that was done 5 times. Now what that means is, if we're going to go looking for Cranbourne meteorites, where would we look? Well, if you looked here at Pakenham, you found a couple of smaller ones, tens of kilograms. There could potentially be very large ones downrange of it, in other words, down to the southwest. So if you're going to go out looking for more meteorites, that's where you would go. At Clyde, they found one very large, one large one that's downrange, so there could be smaller ones uprange that haven't been found. Devon Meadows, well, they may have found absolutely everything there, given the number that have been found. However, there's no proof that you have found everything. Cranbourne South, they found the small ones, but there could potentially be big ones still to be found downrange to the southwest of that spot. And at Pearsdale, well, they probably found both, but it's hard to know. There could be others yet to find. So they found the heavy ones and also found a light one. So if we were going to go looking, the best bet is obviously to look for the big ones, because they're ones that you're going to readily detect with a metal detector, even if it's buried fairly deeply. So what you would do is you would try to look to the southwest of the Pakenham ones that fell there, and you would also look to the southwest of the one, number 3 at Cranbourne South, to maximise your chances. So in other words, it's a strategy if we're going to look for the next Cranbourne meteorites. And one of the activities that we might do in the near future is to approach Cranbourne Shire to see if they're actually interested in mounting a search, a systematic search for this, potentially even using local schools to scour places like their school grounds and local reserves, and mobilise people to look in their backyards, because some of these finds are now in built-up areas. They weren't originally, but the urban sprawl has slowly moved out. Well, with that, given the hour, I think I will put the lights on and close the meeting if anyone, unless anyone has any questions.
No question, but I have a statement.
A statement?
We had one stage when Steve Malone went to Cranbourne Council and visited the area. We actually walked out by that bus here and had it at the Cranbourne Grindstones. It was awfully heavy. I got the figure that was 36.
Yeah. That the one was the 23 kilogram number 12 that you're talking about.
Brick size.
Yeah, the Cranbourne Shire Council actually gave it to us, and I believe it was in a shoebox, and they were using it as a doorstop or something to keep the door open.
We bought the long
extremely strong. We had actually attempted to approach Cranbourne Shire Council when we ran the last Bastrop to try and get them to lend it to us again, but they wouldn't do it a second time. They suddenly realised it was of state importance.
Yeah, well, when we were talking to them, I couldn't hear less than that.
Yeah.
Well, it was, now they're probably better than it was worth knowing.
They don't want to donate, they don't want to send it to the museum.
We see the museum, I think it has been donated to the museum, but the museum, as part of the bicentennial, actually, as a goodwill gesture, had given it to them as on permanent display purposes. So now I believe it's actually in the cabinet.
Yes, it is.
Yeah, I believe it's in the cabinet, but you can actually go and have a look at it whenever the council offices are now open.
But there's a fair bit of development going on, sort of, south of Pakenham, southwest of Pakenham, southwest of very to Clyde. There's sort of scraping the top off the ground there with scrapers and, putting these lakes in, and, new roads every day. There's, more ground being hooked up. Are any of these people doing that sort of, one thing you can run over a sort of like a football-sized piece, and that just sort of gets scrape it up and cart it away and dump it somewhere where they come in soil. No one would know.
Well, indeed. I mean, even the ones that were discovered while ploughing, the farmers ploughed it to one side and I'll get that nuisance out of the way and we'll keep on ploughing. And
At least they saw it. These guys are just going to run over and scrape it away and see it.
indeed. So, I mean, there could be ones that are sitting beneath concrete slabs and beneath the road and over the top of them. So unless something is done, I mean, the population is only going to increase and increase, and we might get the ball rolling.
I like flying a helicopter with an anatomical survey on it.
That could be a possibility. Okay, well, on that, I'll close the meeting. Thank you very much for coming. If you're interested to feel how heavy a metal iron meteorite is, feel free to come and feel how heavy this one is, one of the Gibeon meteorites.
Well, you'll be watching.
I'll be watching, yes.
Sure, it's nice.
Geological survey of the article.
Only two what?
They did have one a number of years ago, but all it was someone else.
Good to see you, sir. Good fun had by all. That was good.
It was a bit nice friends. And that each other as well. Not that I was bored, but I felt relaxed and sort of, yeah, it's nice.
The one I showed on the screen, was that one you'll see the pen? Oh, yeah, well, that's right. It did look a little bit bigger. Well, that would be one of the things that we would have planned as a society. It's a big map of the area. Can we actually approach the owner and search that area and then you can find anything we can cross them and take the years. But how long will it take you to cover Canada to Texas?
Yeah, so that's why.
That could be well.
How many of you there are? He does, yes.
The national calendar.
Yes, it's inspiration. It could, yeah, it could break.
I thought there might be one I was keeping an eye out for it.
Yeah.
It's a big request, we should have to consider to watch them.
Peter, I assume
I was doing something else inside. I was actually getting a call from the night. Setting up a slide, again, maybe like an essence of making it a choice. Well, I was giving it a what it was like, I thought it was increasing.
Actually go on by any of them. I bought that one at the...
A bit chilly down there.
Kenny, you feeling trying to help me with the day?
That one I bought it Friday.
So where are you working exactly, John?
Department of Geography and Environmental Studies at Melbourne Uni.
You see little ones like a garden walk around $67.
Joining you?
Yes.
I'd actually
I was maps for stuff. Oh, yeah, obviously the departments and also other departments that require.
I'll see you later. Thanks very much.
The job is advertised via email. I work for the Mapping Sciences Institute.
Good on. You cracked it.
Yep.
Well done.
See you later, friends.
Yep.
See ya. Goes down the far end.
One of these here. I'll just put it up. Here. Dom's really good. My video. I think he's actually got it. Oh, here it is.
Can I have the keys, please?
Yep.
This one here.
I must have to wait for what to pick up here first.
Put them over there, shall I? Oh, that's all right. It's over here.
Problems.
Yeah, sure.
Label it somewhere. Box. Yeah, just so they know what's
Some total tonight.
bag.
There's the
When you put this cord in the
That
pilot,
goes in there as well.
in the pilot case,
You're right. Leave it, take a few people home, so.
Right, yeah, Don's got the keys.
Oh, he's okay.